Welcome to Volume, Practice number 2. At the top of the sheet, you will find the formulas to calculate the volume of a rectangular prism, length times width times height, a triangular prism, base times height divided by 2 times h, and finally for the cylinder, which is pi times r times h. Let's take a look at the first page. On this page, you'll just be naming the solids. Pause the video, name the solids on your own, and turn on the video when you've completed problems 1, 2, 3, and 4. Please pause the video now. Turn your video back on to find out the answers. You can see that number 1 is a sphere. Number 2, with its triangular base and only one base face, is a triangular pyramid, letter B. Give yourself a C if you got that correct. And for number 3, as you look at the base face, you see it has 5 sides. It's a pentagon on the bottom and a pentagon on top. Since it has 2 bases, it's a prism. So the answer is A, pentagonal prism. Give yourself a C if you got that correct. And finally, number 4. We have a 6-sided base face known as a hexagon, and only one base face, so we know it's a pyramid. So for this one, you should say D, a hexagonal pyramid. Give yourself a C if that's correct. Now let's move on to the next page. And remember, you have formulas at the top of this page, so please feel free to use them when calculating volume. And you will also need a calculator. Let's take a look at page 2. On this page, you will be identifying the parts of a solid and counting them up. It states, given the solid, name the solid, determine how many faces, how many base faces, how many edges, and how many vertices. Well, let's start with the name of the solid. It has a triangular base face and a second one on top. So we would call this a triangular prism. Please take a moment and write that down for letter A, triangular prism. For letter B, we have to count the faces. Well, we have a face on the bottom, a face on top, a face on the right, a face on the left, and of course, the front face. That means there are 5 total faces. Please write that answer down for letter B. We know we have 5 faces. That's the answer to B. But how many of them are base faces? Well, we have 1 on the bottom and 1 on top. So there are 2 base faces for letter C. That's the answer. Write that down. Now let's check the edges. We can mark the edges with little hash marks. We have 1, 2, 3 edges on top. In the middle, we have 1 in the back and 2 edges in the front. So that's another 3. And on the bottom, we have 1, 2, 3. Please mark those along with me. Altogether, if we add it up, we have 9 edges. 9 edges. That's the answer to letter D. And as far as our vertices go, we have to find out for letter E how many vertices. Well, yep, let's use a dot. We have 1, 2, 3 on top and 1, 2, 3 on the bottom. Altogether, that's a total of 6 vertices. Write that down. That's the answer to letter E. Now, you're going to do number 6 on your own. Let's move on to number 7 when you're ready. Pause the video, answer A, B, C, D, and E when you're ready, and then turn the video back on, and we will check your answers together. Then move on to number 7. Its official name is a rectangular prism. Give yourself a C if you got that correct. It also looks like a cube, but we can't be sure it is a cube. How many faces? Well, there are 6. 2 top and bottom, 2 front and back, and 2 faces side and side. As far as base faces go, there's 1 on the bottom and a base face on top, so there are 2. When it comes to edges, there are 4 edges on top, 4 edges along the side, and 4 on the bottom. That means 12 altogether. And when it comes to vertices, there are 4 on top and 4 on the bottom. That's a total of 8. Give yourself a C for the ones you got correct. Let's move on to number 7 and find the volume of this triangular prism. On this page, it states, find the volume of the triangular prism. We know our triangular base face has a height of 12 and a base of 10. And for this particular solid, we look at the front cover and we see the formula. V equals B times H divided by 2 times big H. We know that the 10 and the 12 will go in to the triangle formula. We're going to take 10 times 12 divided by 2 times, and this is 4 yards high. Let's figure out the triangle part first. Well, 10 times 12 is 120, but we're going to have to divide by 2. 120 divided by 2 is 60 times 4 layers high. Grab your calculator. 60 times 4, or think about 6 times 4, is 240 cubic yards. Make sure you copy down these steps. Pause the video if you need more time. I'll be checking your work. On the line, you can write 240 cubic yards. Now let's take a look at our next problem, problem number 8. Problem number 8 is a rectangular prism, and we need to find the volume of this solid. It has a length of 15, a width of 10, and it is 8 inches high. The formula for this, write this down please, volume equals length times width times height. We're going to multiply 15 times 10 times 8 and calculate the volume of this box in cubic inches or inches cubed. Pause the video, pick up your calculator, and multiply 15 times 10 times 8. Pause, please. You should have gotten 1,200 cubic inches. Please write that on the line. Make sure you have the 3 steps shown on your paper. Let's move on to problems 9 and 10. Problem number 9 states, find the volume of the solid. Use 3.14 for pi. We're given a diameter of 12 inches all the way across. Well, what we really need to know is the radius. So if the diameter is 12, we can cut that in half to get a radius of 6. And the overall height, well, that's just 9. The formula from the front of the packet for finding volume of the cylinder is volume equals pi times r times r times h. Make sure you show your work. We're supposed to use 3.14 for our pi value. Our radius is 6 times 6, and we know the cylinder is 9 inches tall. Grab your calculator and punch that in. Find the volume of this cylinder in cubic inches. But before you pause your video, let's take a look at the next cylinder, which happens to be tipped on its side in problem number 10. It states, find the volume of the solid, use 3.14 for pi. In this case, we're given a radius of 7 and a height of 11. We're good to go. We're going to use the same formula as above. We're going to use 3.14 for pi again, times a radius of 7 times a radius of 7 times a height of 11. You're going to find the volume again of this one in cubic inches. Pause the video right now and hold. Grab your calculator and multiply this problem as well. When you're ready, turn the video back on so you can check both problems 9 and 10, but do not turn the video back on until you do your own calculations. Pause now. Here's the answer for the first problem. That's the answer to problem number 9. Now let's check problem number 10, but give yourself a C if you got it correct. For number 10, you should have gotten this answer. Check your work, give yourself a C if you are correct. Let's move on to the next problem. Problem number 11 is a comparison problem. You need to find the volume of each sand bucket. Bucket 1 is a cylinder, so you will use the formula V equals pi times R times R times H. And bucket number 2 is a perfect cube with a length of 11, a width of 11, and the height of 11. So you will use the formula volume equals length times width times height. Now these drawings are not to scale. So don't decide based on which one looks bigger. You're going to calculate the volume of each to see which one is actually bigger. And then you'll find the difference in each of the volumes. When it comes to the cylinder, pi should be 3.14 times a radius of 8 times 8 times an overall height of 14. When you're ready, get your answer and write it here for the volume of bucket number 1. For bucket number 2, you're going to take a length of 11 times 11 times 11. You're going to calculate your answer, write it down there, but also place it on the line. Continue to ask questions, answer questions as you go down the page. Pause the video and do your work for problem number 11. When you're completely done with all the questions on this page, turn the video back on. Once you find the volume for each of these buckets, you will then determine which container holds the most sand, number 1 or number 2, and how much more sand does it hold. You're going to have to subtract the two volumes, find the difference, and then write the difference here on the line. You will check your answer with the answer key that will be provided at the end of this video. Let's move on to the next page. But finish this problem first. On this page, it states, Bobby wants to fill a rectangular pillar with sand. Find the volume of the pillar. Well, the length is 7, the width is 6, and the height is 10. Volume for a rectangular prism is length times width times height. Well, we're going to take 7 times 6 times 10 and multiply those values together to get the entire volume of the pillar. Punch that into your calculator right now. 7 times 6 times 10. You should have gotten a volume of 420 cubic feet. Now Bobby wants to fill 1/4 of the pillar with white sand and 3/4 of the pillar with black sand. What is the volume of each type of sand? We need to take the total volume of 420 and divide it into 4 equal parts. Punch into your calculator 420 divided by 4. That means each part is worth 105 cubic feet of sand. 3 of those parts are black and 1 part is white. The white sand only will use 105 cubic feet of sand. But for our black sand, we have 3 parts made up there of black sand. So we're going to add that up. For the black sand, we're going to have 315 cubic feet of sand. We'll definitely have to buy more black sand than white sand. Well, sand is sold by the bag. Each bag is 30 cubic feet of sand. And for our white, we're going to need 105. How many bags of white should he buy? And how many bags of black sand should he buy? Well, let's start with our white sand at 105. One bag is 30. 2 bags at 30 each would be 60. 3 bags would only be 90 cubic feet. And a 4th bag, if we add it all up, would be 120 cubic feet. Well, 3 bags would not be enough. I may have extra, but I'm going to need 4 bags of sand. The other way to do this is to take 105 and divide by 30, because each bag has 30 cubic feet of sand. 105 divided by 30 equals 3.5 bags. But we're going to have to round that to 4 full bags because we can't open up a bag in the store. So when it comes to the black sand, let's take 315 and see how many bags of 30 cubic feet we can use. Make sure you're copying down the work. Take 315 divided by 30. Well, that's 10.5. But you're going to have to round that to 11 full bags of black sand. Make sure you have all the notes for this problem. Pause the video if you need more time. Make sure you've taken down all the notes. When you're ready, turn the video back on, and we're going to go back and take a look at problem 11 and correct that together, the sand bucket problem. Make sure you have the notes for problem 12, and let's check problem 11 when you're ready. Give yourself a C if this is what you have for the volume of the cylinder. Give yourself another C if this is what you came up with for the volume of the cube. Clearly, bucket number 1 holds more sand. How much more? Let's see if you agree with my answer. For letter D, you should have gotten the following answer. Give yourself a C if you subtracted to find the difference. This concludes the volume video. Practice number 2.